What's up, YouTube? Hammond Dr. Kemp here. Today I want to talk about Leslie Amplifier output transformers. Now, the purpose of an output transformer is to match the impedance between the output tubes in the amplifier, like the 6550, and the speaker of the Leslie cabinet. So you need a match between the impedance of the tubes and the impedance of the speakers in the Leslie cabinet. Like, here's an example, like the V21 here. Okay. Now, on the output side of the transformer, and I'll show you, here's a transformer. This is a output transformer. On the tube side of this transformer, you're getting over 400 volts and up to 100k ohms of impedance. On the speaker side of the transformer, you're dealing with about 20 volts or so, and from 10 to 16 ohms of impedance. So that's why we use a 16 ohms upper driver in the Leslie and the 16 ohm base woofer in the Leslie, because the output transformer, that's what it is designed to deal with. Okay, now how is that designed? Well, what you have are windings of copper wire that make up the transformer. There are many more copper wire windings on the tube side than there are relative to the speaker side. In fact, according to the research that I've done in looking at the this particular transformer, the Leslie Amplifier transformer, output transformer, there's a ratio of between 15 to 5 and 16 to 1. That is for every 5 windings on the tube side, you get 1 winding of copper wire on the speaker side, or and in some cases to 16 windings of wire on the tube side to 1 winding of wire on the speaker side. And so that's referred to as the winding ratio of a transformer. So that's what allows for the power in the amplifier, in the transformer, to be stepped down from the power here in the transformer to what is emitted in the speakers, to what the speakers are able to handle. The speakers can't handle the amount of volts that the tubes can handle. They can't. The speakers can't handle that. So you have to have a transformer to step the amount of volts down for the speakers to be able to handle what the transformer is capable of emitting. Okay? Now, let's take a look at a Leslie. This is a Leslie 147 I have here. And you can see different types of transformers. And I'll just the one that I'm focusing on is this. This is your output transformer. I'll do another video, a couple of other videos, maybe one on the power transformer, and then another one on the choke here. Okay, but today I'm talking about the output transformer. Okay, so this is where the output transformer is located on the Leslie amplifier, and in order to evaluate it, what you have to do is you have to connect. The way I do it is I actually connect the amplifier to live to the organ, and some other people use other equipment to generate the current, but I use an organ, and I also connect it to a load, to a speaker. In fact, I have a setup over here that I've demonstrated in some other videos. But here's my setup. And what I do is I put the amplifier, just lay the amplifier with tubes in it over here, like this. Set it in there like that, and I'm able to plug. I have a hole here that I'm able to plug into here, into the amplifier, and I have a crossover. Here's the crossover cable. Crossover sitting right down there in the bottom. There's the crossover. And it's connected to this vintage Jensen V21 speaker, and that's how I load it. Turn everything on, turn the organ on, and then I'm able to check the voltage coming from this output amplifier. And I've done, you have schematics that gives you the voltage expectations, but also I've done so many of these that I've been able to write down the voltages at the different locations, and based off of good, strong functioning even new amplifier, taking a new amplifier and use that as a baseline. And I've written down all of the, in fact I have the numbers right here on my base. I have the numbers written down for my output transformer, power transformer, and for my choke. So I have the numbers already written, and so I can determine when I look at this whether or not, comparing them to the numbers that I have written down here, which is my criterion, whether or not this output transformer is functioning as it should. And when it is not functioning as it should, then it means that I have to remove it and replace it with another one. These are very, very expensive. I mean, it seems like the prices on these are going up every year. Some people don't know how to find them, but there is a company that is manufacturing, a company that manufactures these transformers, and last time I looked in terms of the retail price on these, they were well over $100. Well over 100. I remember when I first started fixing amplifiers, they were like $65 or $70, something like that, years ago. But now they are well over like $110, up to around $110 retail, just to buy one of these. That's very expensive, which suggests that the cost of even the amplifiers are going up. So, because the components to go in them, when that goes up, that'll jack up the price of the amplifier overall. So, you don't want to have to put in too many of these in your amplifiers. So you want to make sure that you're not overworking this thing. How do you do that? Well, use the appropriate speaker for the transformer that you have. So you want to make sure you're using 16 ohm speakers. You don't want to use 8 ohm speakers in your Leslie cabinet. That will cause you to overwork your transformer. You don't want that, and because, I mean, these things are too expensive for you to have to keep replacing, because you're trying to use some house speakers in your Leslie. Just get the appropriate 16 ohm rated upper driver, 16 ohm base woofer, and that takes that pressure. That takes that pressure off of that transformer, and your transformer can last as long as it should last in your Leslie amplifier. Well, I think that's enough for this session. This is Dr. Kemp, Hammond Doc, saying to you, until the next time, peace out.